All right, in our last video for section 1.3 on fractions, we're going to talk about adding and subtracting fractions. Probably the most complicated part of fractions because when we're adding and subtracting, this is when we need our common denominators. Where when we multiply, remember our rule is just multiply across the numerators and multiply across the denominators. And when we divide, we know that division is really the same thing as multiplying by the reciprocal. We keep the first fraction, we change the division to multiplication, and then we flip that second one. And then we just multiply across the tops and multiply across the bottoms. However, when we're adding and subtracting fractions, we need to make sure that we have a common denominator. So when those denominators are the same, then we can add and subtract fractions by simply adding or subtracting the numerators and keeping the same denominator. Let me show you a quick example. If I have 1/3, one piece out of 3, and I want to add it to another 1/3, one piece out of 3. If I were to take these two and add them together, then I really have 2 pieces out of 3. Really, what we just said is 1/3 plus 1/3 is really 2/3. You notice that since our denominators were the same, we could more easily combine my 1/3 plus my 1/3, and we end up having 2/3 in the end, where we just add the numerators and keep those denominators. As long as we make sure that we have that common denominator, we can just add the tops and keep the common denominator. Let's do a few quick examples that already have common denominators. In example number 7, it asks us to add and simplify. So when I have 4/8 and I want to add it to 5/8, and since I'm adding, as long as I have a common denominator, then I can simply just add my numerators together and keep that common denominator. So 4/8 plus 5/8 is really a total of 9/8. If I can reduce that, I always want to reduce my final answer. So is there a factor of 9 that's also a factor of 8? Not that I can think of, so it looks like 9/8 would be my final answer. So what about B? If I have 2/5 plus 4/5, as long as I have a common denominator, I should be able to add those two fractions together. So 2/5 plus 4/5 is really 6/5. No common factor, so it looks like that would be my final simplified answer, 6/5. Okay, so now what happens when we don't have a common denominator? Well, I'll show you a quick example of why it works, but you might need some more visual representations. And so there's a cool video that Dr. Pample, one of our GCC instructors, actually made that kind of gives you some more examples, visual representations of why we need that common denominator in order to be able to add fractions together. So just a real quick explanation. If I ask you on example number 8 to add 2/3 plus 1/2. So I've given you a picture of 2/3, and then I've given you a picture of 1/2. And when we try to add them together, it's kind of hard to figure out how much that is because they're not broken down into the same units, the same common denominator. And so what we would want to do is we want to break each of those down into the same whole units. And so I would take this thirds and I would break it down 2 more times for a total of 6. And I would break my halves down 3 more times so that they were broken down into the same total amount, 6 in each, right? And so really, this is 1, 2, 3, 4, 6. And the second one is really 1, 2, 3, 3, 6. And doesn't that make sense? 2/3 is the same thing as 4/6, or 4/6 is the same thing as 2/3. And 3/6 is the same thing as 1/2. So then when I go to add them together, if I take this 4/6 and I add another 3 to it, don't I have 7/6 total? So as long as I have that common denominator, I should be able to just add these numerators and get a total of 7/6. But that only works, or it works more easily, when they're out of the same whole amounts. So common denominator of 6, then I can add all of the little pieces together because they're equivalent. All right, if you need some more visual representation, like I said, watch that video that Dr. Pample made. I've posted it in Canvas, but from now on, what we're gonna do is use the algorithm where anytime we're adding or subtracting fractions, we need to get that common denominator so we can add or subtract them together. So look at B with me. B says I have a 9/8 plus 4/5. And I can't really add eighths with fifths because they're not kind of out of the same amount. So what we have to do is figure out what our common denominator is. We need to figure out what I can turn 8 into and 5 into. So is there a number that 8 goes into and 5 also goes into? Well, you might have noticed that they both can go into 40. So let's make our common denominator 40. That means I need to figure out how to change 8 into a 40. I'm going to multiply the numerator and the denominator by 5 to keep it balanced. When I do that, 9/8 is really the same thing as 45/40. When I multiply by that factor, I can make it bigger, just like I can take that 45 over 40 and reduce it smaller if I needed to into 9/8. But I could multiply by a factor of 5 on both the numerator and the denominator. That will also help me figure out how to get 5/4 into a common denominator of 40. So what factor do I need to multiply 5 by to get it to be 40? Let's multiply it by 8. So I can multiply the top and the bottom by 8, and I can turn that fraction into a 32 over 40, the same thing as 4/5, just a bigger version of itself. But now that I have common denominators, I can more easily add my pieces together. So if I have 45 over 40 plus 32 out of 40, then I can add my numerators together and keep my denominators and really say that I have 77 out of 40. We can look for a common factor and try to reduce 77 over 40, but I don't know if there is any, so it looks like that would be my final answer. So getting that common denominator is very helpful so I can add all my pieces together. All right, let's look at number 9. We'll do a few more examples to get lots of practice with this adding and subtracting. In example number 9, it asks us to perform the indicated operation and, if possible, simplify. So it looks like in A, we're subtracting. And remember, anytime we're adding or subtracting, we need to make sure that we have common denominators. So right now, we have 7/10 minus 1/5. So we've got to figure out what our common denominator would be. Now, if you're not sure what your common denominator is, what you can always do is break down your denominators into factors of. For example, if I had this 7 over 10, what I could really do is break down 10 into different factors, prime factors if that helps. For example, oops, what just happened there? 5 times 2 is 10, right? And then if I break down 5, well, 5 doesn't really break down. He already is a prime factor, so he breaks down into just 5 himself, right? Because he's already a prime number. And so this one only has a factor of 5, where 10 has a factor of 5 and 2. And if they need to be common denominators, they all have to have the same factors. So they both already have 5s, but what is this one missing that the other one has? What factor is it missing that the 10 has? Isn't he missing this 2? And so what I need to do in order to get them to be common denominators is I need to multiply this denominator by 2. Now remember, if I multiply the denominator by 2, I have to multiply the numerator by 2 to keep it balanced, so it's still the same fraction. So really, my problem turns into 7/10 minus 2/10, or 1/5 if you reduce it. So it looks like the 7 over 10 already had that common denominator of 10, so I didn't have to multiply it by anything. But I did need to take the 1/5 and multiply the numerator and denominator both by 2, so I can get it to be a common denominator of 10. And now that they have common denominators, I should be able to subtract their numerators and just keep that common denominator. So 7/10 minus 2/10 is really 5/10. Now, you might have noticed that there's a common factor out of 5 and 10 that can be reduced. And so 5 goes into 5 once, and 5 goes into 10 twice. So I can actually reduce my final answer of 5/10 into 1/2. All right, look at B with me. Let's do another subtraction problem. Maybe you can pause the video and try getting a common denominator first to see if you get the same thing I do. So 9/20 minus 1/4. If they need a common denominator, what number does 20 go into and 4 go into? I guess you could say 80, but that's a pretty big number. If there's a smaller number, it might be easier to use a smaller number if possible. So is there a smaller number that 20 and 4 can both go into? Well, I noticed they can both go into 20. So the 9 over 20 doesn't have to change. He already has a denominator of 20. But I need to change that 4 into a common denominator of 20. I'm going to multiply then by a factor of 5, both the numerator and the denominator. That changes the 1 over 4 to a 5 out of 20. So now I have 9 over 20 minus 5 over 20, which is really 4 over 20. Let's reduce if we can. So what factor can I reduce it by? It looks like 4 can go into both of those, so I'm going to divide both the top and the bottom by a factor of 4, and that leaves me with 1/5. So 9 over 20 minus 1/4 is really 1/5. All right, both of those were some subtraction problems. Now let's look at these next couple. These next couple are a little bit different because we're not subtracting or adding anymore. If you look at C, what are we doing? It looks like we're multiplying, remember? And so when we multiply, we don't need a common denominator. Remember that when we multiply, we really just have to multiply our numerators together and then multiply our denominators together. So it's really important that you keep these rules straight. We only need common denominators when we're adding or subtracting. So on C, when I'm multiplying, I'm just going to take my numerators and multiply them and my denominators and multiply them. But 8 doesn't really look like a fraction. But let's make it look like that. Let's take our 8 and write it as 8 over 1. And then we have our 5/12, and now I can simply multiply across the tops and multiply across the bottoms. 8 times 5 is 40, 1 times 12 is 12, and let's see if I can reduce both of those by a certain factor. I know that 4 goes into both of those, so 40 divided by 4 is 10, and 12 divided by 4 is 3. So I have a final reduced answer of 10/3. All right, look at D. D looks kind of confusing. But really, all it is 5/6 divided by 25 over 9. So they're just using a fraction bar to represent division again. Remember that fractions are really just the same thing as dividing. If that's too complicated, then you don't have to write it with the fraction bar. You could actually just write it with the division sign. For example, like this. We have our 5/6, and we want to divide it by 25 over 9. If that looks better to you, then write it like that. It means the same thing. But now we're dividing. And remember, dividing is really the same thing as multiplying by the reciprocal. So I'm going to keep the first fraction. I'm going to change the division to multiplication. And I'm going to reciprocate the second fraction, flip it. And remember, multiplication doesn't need common denominators. I now just simply multiply across the tops and multiply across the bottoms. I ended up with 45 over 150. It looks like both of those are divisible by 5, so I can reduce by a factor of 5, and I end up getting 9 over 30. Ooh, and aren't both of those divisible by 3? So I'm going to divide both of those by a factor of 3. I end up getting 3 over 10. It looks like that's my final reduced answer, 3 over 10. So rewriting it makes it look a lot more simple, right? And then we can change our division to multiplication and then reduce from there. So remember our rules. When we multiply, we just multiply across the numerators and denominators. When we divide, we multiply by the reciprocal. And when we add or subtract, we have to have those common denominators. Make sure that you practice all of those different fraction ideas before you move on, because that's a huge foundation of mathematics from now on.